today we're going to be working with 2.5 transformations. We're just going to do a few different kinds of transformations today. I have our first example written down for us. It says use the graph below to graph capital F of x equals lowercase f of x plus 2. And they're going to give you a graph to start with. Okay, so what they want you to do is rewrite this graph using this new equation. Okay, so they're going to be doing something to the equation that's going to transform your graph. In this one, they're adding 2 to the left side. Well, whenever you add something or subtract something from the complete left side, that moves your graph up and down. If you're adding something, that's going to move it up. If you're subtracting something, that's going to move it down. So this graph is going to move up 2 units. So you just take each point that you're given and move it up 2 units. So I'll move that one up 2 units. I'll move that point up 2 units. And I'll move this point up 2 units. Okay, and then just connect the points the same way. And that's your new graph. I'm going to label it F, capital F. Okay? You can put your new graph on the same graph. Just make sure you label it, or you could put it on a new graph if you prefer. Okay? Some students don't like shifting the graph. They like to actually write out the points. So let me show you another way you could have approached it. Okay, let's see. The points we started with were 0, 0. 2, 2, and 4, 0. Okay, and again, this is telling us to add 2 to our y value. So we're just going to add 2 to our y values here. So that's going to make this one 0, 2. Add 2 to our y value, so that one's going to be 2, 4. And add 2 to our y value, so that one's going to be 4, 2. And as you can see, those are the points that we got when we went up 2 units. 0, 2, 2, 4, and 4, 2. Okay, so whichever way seems better for you, approach the problem that way. Okay, let's look at another example. Example 2. Write the function whose graph is the graph of y equals the cube root of x but is part A shifted to the right 2 units. Okay, well, they want you to no longer graph it. We're just going to rewrite our equation doing what it tells us to in the problem. Okay, so like we had in this first one, if it's added or subtracted to the left side, that moves the graph up or down. If it were added or subtracted to just the x variable in the problem, that's what moves the graph left and right. Okay, and it's actually the opposite of what you think. If it's x minus something, then it's going to move it to the right. If it's x plus something, then it's going to move it to the left. Okay, so in our problem, it says we want it to go right 2 units. So that means we're going to be subtracting the 2, and we're going to be subtracting it from the x. So if we rewrite this, we'd write y equals the cube root of x minus 2. And notice, I made sure the cube root extended completely over x minus 2. The cube root is kind of like a parentheses for us. It's putting that x minus 2 together. Of course, it's fine if you want to put the parentheses in there as well. Okay, so either way works. Let's write down another one. Part B, shifted to the left 5 units. Okay, again, left and right, you're just going to be doing it to your x variable. We're going left 5, so that means this time we're going to add 5 to our x. So we're starting with our same equation, and we'll just change it. So we've got y equals the cube root of x plus 5. Okay, and this time I won't add the parentheses because again, you don't need it as long as you make sure that that cube root goes over both the x plus 5. Okay, part C, shifted down 3 units. Okay, well this is like our first example. We want to shift it down 3 units. So that's where we either add or subtract from the total left side. Okay, and we're going down, so that means we're going to subtract the 3. So I'm going to write y equals the cube root of x. Be careful, make sure that that cube root is only over the x now, because we want the minus 3 to be done to the complete left side. Okay, our last example. Use the graph below to graph capital F of x equals lowercase f of negative x. Okay, so this is the last kind of transformation I want to look at today. Notice it matters where they're multiplying a negative 1 in the problem as well. If they're multiplying the negative times the x, that changes the sign of the x, so it's going to flip over the y-axis. If they multiply it times f of x, that's like multiplying a negative times the y, that would flip it over the y-axis. So in our example, we're flipping it over the y-axis. Let me write down our graph. They give me the point 0, 0, the point 1, 2, and the point 4, 2. Okay, again, this is going to flip it over the y-axis. So we're just going to flip all these points over the y-axis, or reflect it over the y-axis. So this one's at 0, 0, so that's not going to change. This point is at 1, 2. Well, now it's going to be at negative 1, 2. This point is at 4, 2. Now it's going to be at negative 4, 2. And we'll just connect those points again. Okay, so this is what we started with. This is our new graph. And you can also use the points like we did in the first example. So this one started off with 0, 0, 1, 4, 1, 2, and 4, 2. Okay, and it's just changing the sign of your x. Well, 0, there's no sign, so we'll just keep that 0, 0. This one is negative 1, 2. And this one is negative 4, 2. And as you can see, those were the points that we got. So try out the homework and let me know if you have any questions.